JavaScript has a reputation for being single-threaded. This means it can only do one thing at a single moment in time. Imagine a single lane of traffic. Only one car can pass through at any given point. If one car stops, the entire line of traffic behind it comes to a halt. This is what we call blocking. JavaScript, by its fundamental nature, works in this exact way. It processes one command, then the next, and so on in a strict sequence. This single-threaded model is simple and predictable, which makes writing code easier to reason about in many scenarios. However, the modern web is complex and interactive. Users expect to click buttons, scroll pages, and fetch data from servers without the entire application freezing. If JavaScript could only do one thing at a time, any long-running task like a network request would freeze the user interface completely. This would create a terrible user experience. The browser would become unresponsive until that single task was finished. To solve this problem, JavaScript environments like browsers or Node.js, provide us with tools to handle these long-running operations without stopping everything else. These tools are the web APIs. This is where the magic of the event loop comes into play. It is the core mechanism that allows JavaScript to feel like it's doing multiple things at once, even with its single-threaded constraint. The event loop is a constantly running process that manages and coordinates the execution of code. It's what lets us write asynchronous code that can start a task now and finish it later, without blocking the main thread. It works behind the scenes, orchestrating the flow of operations between the JavaScript engine, the web APIs, and the various task queues. So, the event loop is not part of the JavaScript engine itself, but rather a feature of the hosting environment. It is the unsung hero that enables a responsive and dynamic user experience. It creates the illusion of concurrency, making JavaScript powerful enough for today's demanding applications. Think of it as a traffic controller for JavaScript's single lane of code. It ensures that traffic keeps moving smoothly, even when some cars need to take a detour for a longer task. Understanding this controller is the key to mastering asynchronous JavaScript and building non-blocking applications. To understand the event loop, we must first look at its two most important companions, the call stack and the task queue. The call stack is a data structure that keeps track of where we are in the program. When a function is called, it is pushed onto the top of the stack. When that function finishes and returns, it is popped off the stack. This happens for every function call in your synchronous code. It's a last-in, first-out system. If you call function A, which then calls function B will be on top of the stack, followed by function A below it. Now let's consider asynchronous operations like set timeout. When the JavaScript engine